All right, now I'm going to do a video that's focused on just graphing lines, linear equations. This is something that a lot of you do have experience with. If you took Math 98, this is what we did in Chapter 3 of Math 98. So linear equations you should be a little more familiar with than you are the others. Okay, so we graphed something in this form earlier. We graphed 2x minus 3y equals 12 earlier, but I thought I'd put another one where the x and the y were on the same side. Sometimes you have y on a side by itself, which opens up another possible way of graphing that if you remember anything about slope and y-intercept. And then you also have lines like this one, x equal 5. That's a special line. You don't see the y in there. And these right here, you kind of have to have a way of thinking about what that even means. So I wanted to look at these three with you. Now, plotting points is still a perfectly acceptable way of doing all of these. So let me go ahead and get my tables ready to go and my coordinate plane on each of these. So we can, on these, we can plot points on all of them. That's what's so powerful about plotting points, okay? But then once you kind of see what's happening, you might have maybe an alternative approach you could use when you're dealing with lines that are in certain forms. Okay, so when the x and the y are on the same side like this, we might want to do what we did on that earlier example, where we plugged in, say, a 0 for x or a 0 for y. Sometimes that works better than other times. So like on this one, if I put a 0 in for y, I love it, because a 0 for y makes the y term cancel out, and I can see without any work that x would have to be 6. Okay, if you do need to see more, if you're brand new to this and that's uncomfortable to you to not write something down, what we did is just put a 0 here. And this was just a formula we're now solving, okay, for x, and that's gone, so x is 6. But in reality, I want you to do as little of that as you have to, because you don't want to make graphing feel super tedious, okay? All right, and then you might think, well, let's go ahead and plug in a 0 for x. Okay, this doesn't work quite as well, because when you plug in the 0 for x, you have negative 4y equaling 6. So it turns out to be not an integer. It turns out to be a rational number, a fraction. So when you divide by the negative 4, you get y equals negative 6/4, which is negative 3/2. All right, when you're graphing, it really does help to have it as a mixed number. So that's the same as negative 1.5. Okay, I still can do it. It's just sometimes I really like to have integers. Now, as you gain more experience with graphing and with finding ordered pairs, sometimes you just look a little more carefully at this and you're thinking, I need this and this to add up to be 6. And so, for instance, I might think I would probably put a negative 1 for y, because that would give me 4 here. And then this would just need to be 2. And so because I've done this a lot, I can kind of look at it and say, oh, you know what? If I put a negative 1 in for y, x would have to be 2. All right, but have the comfort in knowing that you can just pick a number for x, plug it in and work it out, and that's going to be fine, okay? It doesn't have to work out nicely. All right, so now once you get your ordered pairs, you're just going to plot those. So I need to go to 6, 0, okay, 2, 1, and then 0, negative 1.5, okay? Uh-oh, something doesn't look right, okay? See that? I thought I plotted those points, but they're not lining up. So that's kind of why, even though you know these are lines, why you don't just pick 2 points. So first thing I do is I double check that I plotted them right. Okay, 6, 0, that would be over here. That, yeah, I'm pretty sure that's good. 0, negative 1.5, so that would be down about right there. That should be okay. But then, oh, you know what? I plotted 2, 1, and I should have plotted 2, negative 1. That was incorrect. Now I see the lines are lining up, or the points are lining up, and then I can sketch the graph of my line. Okay, so this equation, this line, and that table that consists of some of the solutions to that equation in two variables are just different representations of that relation in two variables. All right, so that one we graph by plotting points. When we graph by plotting points and we use the 0 for x and the 0 for y, 0 for x and 0 for y, those are special points. Those are called intercepts. So like this point right here, it's on the y-axis, so that's the y-intercept, we call it. And this guy here, that would be the x-intercept, because that's where it crosses the x-axis. And so we're still just plotting points, but we're plotting some special ones. X and Y intercepts turn out to be important features of graphs later, so they're sometimes good ones to use. All right, now with the one in the middle, you can still graph by plotting points, but you ought to make it easy on yourself and look at that denominator. Okay, and when I'm trying to do that one, I might think to plug in a 0 for x. That works great. I don't have to do anything. 0 times -1/5 makes that first term go away, and I'm left with 2. If I pick a 1 and I plug it in, that's not so great. It still can be done, but I get a -1/5 plus 2, and that turns out to be -1/5 plus, if I'm doing it by hand, you can do it on your calculator. So I get 9/5, which is 1 4/5. Yuck, don't like that. Wish I hadn't picked that. So I'm not going to pick that, okay? Here's the idea. If you get a problem that's fractional like this, look at that denominator. Things are going to work out great if you pick the right thing. How about a 5? How about a -5? How about a 10? Okay, those are going to work out well. If you put a 5 in, okay, and you do y equals -1/5 times 5 plus 2, this turns out to be -1, nice integer, and you wind up getting your overall answer being 1. And if you make that negative, if you make it y equals -1/5 and you put a -5 in, this is +1 plus 2. But see how it works out nice? The denominator cancels out and gives you a nice integer. You don't need to do 4 points, but I'm just showing you why these choices work out well. If I plugged in a 10, 10 would eliminate the denominator. I'd get -2 plus 2. I'd wind up with a 0 with it. Okay, so if you make good choices on these, you can still graph by plotting points. Just pick multiples of the denominator. So pick 0, plug it in, get 2, then 5, 1, and then -5, 3, okay? And I wind up getting the line looking something like that. Now, if you've done some graphing before, graphing of lines recently, you might recall that if things are in, you kind of clean this up just a little bit. If an equation is linear and in this form, okay, this is called the slope-intercept form. The m is the slope, and the b is the y-intercept. And so you can make use of that to graph. So if you remember that and you want to do that, you can, but that's very specific to lines and lines only, where plotting points works no matter what kind of equation in two variables you have. If you plot enough points, you can get your graph, okay? So if you're using this technique, you would think to yourself that the m is -1/5. So the top number is the rise, the bottom number is the run. So it's telling you down 1, and it's telling you right 5, okay? But you have to have a starting point, so you have to start with this. The 2 is the y-intercept, so it's telling you the point 0,2 is on your graph, so you start with that. I usually tell my students, B is where you begin, and it's always on the y, and M is how you move. Okay, where you begin, how you move. Where you begin, and then how you move. So if you like that, if your equation is in slope-intercept form and you want to use it, you can. So what you would do is you would go down 1 unit, from here. So let me do it in red. So down 1 and to the right 5 units to get to another point on the graph. And then you could connect those to get your line, okay? So that works when you have lines that are in a certain form, okay? All right, and then equations like x equals 5, let me move that. Let me just come down a little bit and do that right here. We have x equal 5. That a lot of times throws people because they didn't tell you anything about the y. So people struggle with what that really means. I think it works good to think of it like this. It's telling you no matter what, your x's are always 5. Your y could be just anything at all. It could be 0, -3, 10, 4. But your x's are always 5. So you're always going to go to the right 5. But this is not the graph of x equal 5. It's not just that one spot. Because you could have been down here at this point, or you could be up here at that point, or that point, or that point. So your graph of x equal 5 is a vertical line. That right there is the graph of x equal 5. So it's a vertical line. Okay. And then once you understand that and you can figure that out and think it through, don't memorize it because you're going to mix it up with these kind. If you had y equals -1, okay, if you had y equals -1, same thought process. Let's see what it does, what we get. Okay, so y is always -1 no matter what. X could be 3, it could be 0, it could be 2, it could be -1, but the y is always -1. Well, what's going to happen there is you might be right here at -1, but that's not the only thing you plot. You could be over here at 2, -1, okay, or -1, -1. And so you actually have the graph of y equal -1 being a horizontal line. So y equals a number always turns out to be horizontal. X equals always turns out to be vertical. Try not to just memorize that because you'll mix them up or second guess yourself. Try to go through this thought process and imagine where would you be on the graph if your y was -1? Or imagine where would you be on the graph if your x, if you're a point and your x is 5, you'd have to be on here. Have some way of figuring it out. Don't just memorize it. But that's what I wanted to look at in this video is just what if we're just focused on linear equations, okay? So linear equations can look like this form, okay? And by that I mean the x and the y on the same side equal to some number, or they can look like this, which is called slope-intercept form, or you can have x equals some number or y equals some number. And that's what I wanted to cover in this video.